In the winter of 1891, in the basement archives of the St. Petersburg Academy of Sciences, a cataloger named Mikhail Volkov was sorting through seized documents from a monastery in the Urals when he found a leather-bound journal that should not have existed. The journal, dated 1817, was written in Russian but contained technical diagrams that resembled no architectural or engineering system Volkov recognized. The sketches showed domed buildings with elaborate internal chambers, not for worship or storage, but for what the annotations described as harmonic amplification. Beside each drawing were measurements, frequencies, resonance patterns, and notes about atmospheric gathering. The journal's author, identified only as Brother Constantine, wrote in precise technical language about buildings that drew power from the air itself through calibrated stone. Volkov documented the finding in his cataloging notes, but flagged the journal as technical content requiring specialist review. The journal was transferred to the Academy's engineering division in March 1891. When researchers inquired about it in 1923, during the Soviet reorganization of Imperial Archives, the engineering division had no record of receiving it. The catalog entry remained, describing the journal's contents in detail. The journal itself had vanished. Only Volkov's notes survived, preserved in a filing system that escaped later purges, describing a technology that Orthodox history insisted had never existed. The idea seems impossible. Buildings that generate power from sound, architecture designed not just to shelter or inspire, but to harness acoustic energy and convert it into usable force. Yet, across the territories once marked on 18th and 19th century maps as Tartary, a vast region spanning from the Caspian Sea to Siberia, from the Urals to Mongolia, structures remain that conventional architectural history struggles to explain. Massive domed buildings with no clear purpose, towers with unusual internal geometries, cathedrals and civic structures whose acoustic properties far exceed what would be necessary for their stated functions. The official narrative attributes these to Imperial Russian, Mongol, or Chinese construction, built for administration, religion, or defense. Yet architectural surveys conducted in the early 20th century, before much of this heritage was destroyed or modified, documented features that suggest a different purpose. Resonance chambers in unexpected locations, specific geometric ratios repeated across buildings, separated by thousands of kilometers, materials and construction techniques that seem designed to amplify and channel very particular frequencies. On May 18, 1902, in Kazan, a German acoustician named Friedrich Hartmann was hired to analyze the acoustic properties of the Sharif Mosque complex, which had been damaged during the Russian conquest in 1552 and partially reconstructed in the 18th century. Hartman had been developing techniques for measuring reverberation in concert halls and cathedrals. He brought his equipment, tuning forks, resonance tubes, and primitive oscillographs, to measure how sound behaved in the mosque's interior. His report, filed with the Imperial Academy in November 1902, described acoustic phenomena he could not explain through known architectural principles. The mosque's dome, when struck at specific points, produced sustained tones at precisely 7.83 hertz, a frequency later identified as the Schumann resonance, the fundamental frequency of Earth's electromagnetic field. Hartman noted that the building contained hidden chambers behind walls and beneath floors that serve no structural purpose but create interference patterns when the sound of certain frequencies is introduced. He documented that these chambers were positioned at mathematically precise intervals, following ratios that appeared again and again: 1.618 to 1, the golden ratio; 3 to 2, the perfect fifth in musical harmony. Most remarkably, Hartman reported that when specific frequencies were sustained in the mosque's interior, a measurable vibration could be detected in metal fixtures throughout the building, not random resonance, but organized pulses that seemed to concentrate at particular points. He wrote, "One gains the impression that the structure was designed as a vast tuning fork, calibrated to respond to very specific acoustic inputs and to direct the resulting energy to designated locations." Hartman's report attracted little attention at the time. It was filed among thousands of technical studies conducted across the Russian Empire's territories. During the Soviet period, when many mosques and churches were demolished or converted to other purposes, References to Hartman's work appeared occasionally in footnotes, but were never pursued systematically. The report itself remained archived in Moscow until it was digitized in 2004. By then, most of the structures Hartman had studied had been either destroyed or so heavily modified that verification of his findings was impossible. Yet Hartman was not alone in documenting unusual acoustic properties in buildings across the region. In 1878, a British railway surveyor named Thomas Whitmore, working on the Trans-Caspian Railway project, wrote in his private diary about a peculiar echo chamber he encountered in an abandoned structure near Ashgabat. Whitmore had some musical training and noticed that the chamber produced different echo patterns depending on the pitch of sound introduced. He described placing stones of different sizes at specific positions within the chamber and observing that when he hummed at a particular pitch, the stones trembled with such violence as to shift position. Whitmore's diary was not published until his great-grandson donated it to a university archive in 1967. The structure Whitmore described was destroyed during the 1948 Ashgabat earthquake. No archaeological study was ever conducted on the site, yet Whitmore's description matches features found in other buildings across Central Asia. Stepped chambers with niches positioned at regular intervals, stone or ceramic vessels embedded in walls at specific heights. Geometric patterns that seem to serve no decorative or structural purpose. In 1913, a Russian engineer named Vladimir Shukhov, famous for his hyperboloid structures and metal frameworks, was commissioned to assess several 18th century buildings in Samara for potential preservation. Shukhov's reports, preserved in the State Archive of the Russian Federation, note that several of these buildings contained what he called acoustic resonators, ceramic or metal vessels embedded in walls and ceilings, positioned to create standing waves at specific frequencies. Shukhov calculated the frequencies these resonators would amplify and found they clustered around particular ranges: extremely low frequencies between 7 and 14 hertz, and higher harmonics in the range of 432 and 528 hertz. These frequencies are significant. Modern research has found that is 7.83 hertz. The Schumann resonance is the natural electromagnetic frequency of Earth's atmosphere. Frequencies around 432 hertz have been proposed as having particular resonance with natural phenomena. Whether the builders of these structures understood these relationships is unknown. What is documented is that they deliberately engineered buildings to amplify these specific frequencies, using sophisticated acoustic knowledge that would not be formally codified in Western science until the 20th century. The question becomes, why? If these structures were designed as acoustic amplifiers, what were they amplifying, and to what purpose? The surviving documentation offers fragments of an answer, though one that raises more questions than it resolves. In 1887, in the archives of the Hermitage Museum in St. Petersburg, a curator named Anatoly Belov discovered a set of technical drawings among materials confiscated from a noble estate during the 1860s. The drawings, executed in ink on heavy parchment, showed cross-sections of domed buildings with elaborate internal structures. The annotations were in Russian, but the terminology was unusual. References to harmonic nodes, frequency chambers, and resonance multiplication. One drawing showed what appeared to be a power distribution system, with lines radiating from a central chamber to various points throughout a city. The caption read, "Atmospheric energy collection and distribution, after the old manner." Belov cataloged the drawings, but noted in his records that he could not determine their date or origin. The style suggested 18th or early 19th century, but the technical concepts seemed anachronistic. The drawings were filed in the museum's technical collection and forgotten. They resurfaced briefly in 1931 during a Soviet inventory of imperial archives, were photographed, and then disappeared again. The photographs survived, showing the drawings clearly, but the originals have never been relocated. The drawings depict technology that Orthodox history says should not exist. Buildings designed not as passive shelters, but as active energy collectors, using sound waves to harness power from Earth's natural electromagnetic field. The concept seems closer to science fiction than to 19th century engineering. Yet the drawings are not unique. Similar documents have surfaced in archives across the former Russian Empire, technical manuals, construction diagrams, maintenance logs, all describing systems for atmospheric energy collection using acoustic resonance. On August 3, 1919, during the Russian Civil War, a Bolshevik commissar named Ivan Kraskov requisitioned a library from a merchant's house in Tomsk. Among the books seized was a technical manual titled Principles of Harmonic Architecture, dated 1798, authored by someone identified only as Master Builder Volkonsky. The manual, written in Russian with technical diagrams, described methods for constructing buildings that would gather and concentrate the vibrations of the atmosphere for the benefit of the city. Kraskov, who had engineering training, read the manual and was sufficiently intrigued to include it in his report to Moscow. He wrote, "The document describes a system of building design that allegedly allowed structures to generate electrical current through acoustic resonance. While this appears to be pseudoscience or mysticism, the technical sophistication of the diagrams suggests the author had genuine knowledge of acoustics and electromagnetic theory, topics not widely understood in 1798. The manual was sent to Moscow for evaluation. Soviet scientists examined it in 1920 and declared it technically incoherent, likely a forgery or work of imagination. The manual was archived and classified. It remained classified until 1991, when it was declassified during the dissolution of the Soviet Union. Researchers who examined it in the 1990s found that while some of the theoretical framework was indeed speculative, the acoustic engineering principles were sound. The buildings described in the manual would function as described. They would amplify specific frequencies and create measurable electromagnetic effects through piezoelectric resonance in certain building materials. Whether such buildings were actually constructed according to the manual's specifications is unknown. Many structures that might have served as examples were destroyed during the Soviet period. Churches, mosques, and civic buildings across Central Asia and Siberia were demolished, stripped of materials, or converted to warehouses and factories. The modifications and demolitions were often poorly documented. What was lost in this process cannot be fully assessed. Yet photographs from before the destructions show buildings with distinctive features, large domes with unusual internal ribbing, towers with spiral staircases that seem to serve no practical access purpose, walls embedded with ceramic vessels in geometric patterns. These features appear across hundreds of structures, suggesting not random architectural flourishes, but deliberate design following consistent principles. In 1924, in Baku, a Soviet engineer named Georgy Orlov was surveying buildings for potential industrial conversion when he encountered a 19th century administrative building with an unusual basement. The basement contained a large circular chamber, approximately 15 meters in diameter, with walls lined with niches of varying sizes. The ceiling was a perfect dome, and at its apex was a bronze fitting that appeared designed to hold something, though what was missing? The floor was marked with circles at regular intervals, each position numbered. Orlov, curious about the chamber's purpose, conducted an informal acoustic test. He brought a bass drum into the chamber and struck it at different positions marked on the floor. At certain positions, the drum produced a sustained tone that resonated throughout the chamber, causing dust to move in visible patterns on the floor. At one specific position, the resonance was so strong that Orlov reported feeling pressure in his chest and a tingling sensation in his hands. He noted in his survey report, "The chamber appears designed for acoustic experimentation, or possibly as some form of sound-based power generation, though the mechanism by which this would work is unclear." The building was demolished in 1927 to make way for an oil refinery. Orlov's survey report survived, filed in the Baku City Archives, where it was discovered in 2003 during digitization. By then, the site had been industrial land for nearly 80 years. No archaeological investigation was possible. The pattern repeats across dozens of similar accounts. Engineers, surveyors, and architects encountering buildings with features that suggest acoustic technology, documenting their findings in reports and journals, and then watching the buildings disappear. The Soviet period saw unprecedented destruction of pre-revolutionary architecture, officially justified by modernization needs and anti-religious campaigns. Yet the pattern of what was destroyed and what was preserved suggests additional factors. Buildings with standard architectural forms, typical churches, mosques, administrative buildings following conventional designs, were often converted rather than destroyed, but structures with unusual acoustic features, with chambers and geometries that served no obvious purpose, were demolished with particular thoroughness. Archives containing technical documentation about these buildings were purged or classified. Engineers who expressed too much interest in the technology were reassigned or disappeared during Stalin's purges. On November 12, 1937, Vladimir Shukhov, the engineer who had documented acoustic resonators in Samara buildings in 1913, was arrested by the NKVD. The charges were vague: dissemination of mystical pseudoscience and preservation of anti-Soviet technical knowledge. Shukhov was interrogated for 3 months about his pre-revolutionary work, particularly his reports on acoustic features in old buildings. He was released in February 1938, but his archives were seized. When researchers attempted to locate Shukhov's papers in the 1990s, they found that the sections dealing with acoustic architecture had been removed from the files. Only index cards remained, listing the removed documents by title: Resonance Systems in Pre-Revolutionary Architecture, Acoustic Power Generation, Historical Examples, Frequency-Based Energy Collection in Traditional Buildings. The destroyed buildings and seized archives left gaps in the historical record, yet enough survived, in photographs, in marginal notes in preserved documents, in the structures themselves where they still stand, to suggest what was lost. A technology based on acoustic resonance, used to generate and distribute power in cities, embedded in the architecture itself so thoroughly that buildings became infrastructure. The principle is not impossible. Piezoelectric materials generate electrical current when subjected to mechanical stress. Quartz crystals, certain ceramics, and some types of stone exhibit this property. If a building constructed with piezoelectric materials is set into sustained vibration at its resonant frequency, it will generate electrical current. The question is scale and efficiency. Could enough power be generated this way to serve practical purposes? Modern piezoelectric systems generate tiny amounts of power, useful for sensors and small devices, but not for powering cities. Yet materials and construction techniques matter. A small quartz crystal produces minimal power. A multi-ton stone structure, if properly designed and calibrated, operating continuously at resonant frequency, might produce considerably more. And if the structure is designed not just to vibrate, but to amplify and concentrate those vibrations through geometric acoustic principles, the potential increases further. In 2007, a team of materials scientists from Moscow State University conducted a study of stone samples from demolished 19th century buildings in Central Asia, analyzing their piezoelectric properties. The study, published in a specialized materials journal, found that many of the stones used in these buildings, particular types of granite and limestone, had piezoelectric coefficients significantly higher than typical building materials. The researchers noted the selection of these specific stone types, sourced from particular quarries, suggests knowledge of piezoelectric properties, though the purpose of such selection remains unclear. The study received little attention outside specialist circles. It was a technical materials analysis, not a historical investigation. Yet it provided physical evidence that builders were selecting materials with specific electromagnetic properties, properties that would enhance the building's ability to generate electrical current through acoustic resonance. On March 15, 2011, in Kazan, construction workers renovating the foundation of a 19th century building discovered a bronze mechanism embedded in the stonework. The mechanism consisted of coiled wire wrapped around a ceramic core, encased in a bronze housing with what appeared to be connection points. An electrical engineer consulted by the construction company identified it as a primitive transformer designed to step up voltage from a low-level input. Carbon dating of organic residue in the mechanism suggested it was installed in the early 19th century, decades before transformers were developed in Western electrical engineering. The mechanism was documented, photographed, and then removed during foundation work. It was offered to local museums, but declined due to lack of exhibition space and unclear provenance. The construction company stored it in their equipment yard. When researchers inquiring about it in 2018 attempted to locate it, the company had no record of its current location. The photographs remain, showing the mechanism clearly, but the object itself has been lost. These scattered discoveries paint a picture of suppressed technology, not through conspiracy, but through the ordinary processes of modernization, ideological transformation, and historical amnesia. Buildings demolished because they were old and religiously associated, archives purged because they contained pre-revolutionary or mystical-sounding content, technologies forgotten because they were embedded in structures that no longer existed and documented in archives that were no longer accessible. The question is not merely what was lost, but what it was replaced with. The Soviet electrification campaign, beginning in the 1920s, brought centralized power generation to cities and towns across the former Russian Empire, coal plants, hydroelectric dams, power lines, a system that required massive infrastructure investment, ongoing fuel supply, and created dependency on central authority. The campaign was presented as bringing modernity to backward regions, replacing primitive conditions with scientific progress. Yet photographs from before electrification show these cities were not dark. Street lighting existed, buildings had illumination, power for basic industrial purposes was available. The official history attributes this to local generators and primitive electrical systems, yet documentation of such systems is scarce. What if the power came from the buildings themselves, from acoustic resonance systems embedded in civic architecture, generating and distributing electricity through methods that required no fuel and no central control? Such a system would have significant political implications. Power generation integrated into architecture means distributed, local control, no central authority needed to provide electricity, no fuel supply to monopolize, no dependency to leverage for political control. The centralized electrical grid, by contrast, creates the infrastructure of state power, literal power, flowing from central generators to controlled distribution. In 2019, in Almaty, Kazakhstan, urban archaeologists conducting a survey before new construction discovered the remains of a cable network beneath a 19th century district. The cables, copper with fabric insulation consistent with early electrical wiring, connected several demolished building foundations. The network had no apparent connection to any known power plant or generator. The archaeologists' report noted, the cable routing suggests a distributed power system, with multiple generation points rather than a single central source. The generation method remains unclear. The discovery was documented in a technical report filed with the Kazakh Ministry of Culture. No further investigation was undertaken. The site was cleared for construction, the cables were removed and scrapped. Another fragment of evidence, noted and discarded. Today, the buildings that might have demonstrated this technology are largely gone. What remains are ruins, modifications, and structures so altered that their original function is unrecognizable. The knowledge of how to construct and operate such systems, if it existed, was lost when the practitioners disappeared and the archives were purged. Yet, the concept has not disappeared. Modern researchers exploring acoustic levitation, sonic manipulation of matter, and piezoelectric energy harvesting are rediscovering principles that may have been known and applied centuries ago. The scale differs. Contemporary experiments work with small objects and minimal power output, but the physics is the same, sound waves creating pressure and vibration. Piezoelectric materials converting mechanical stress to electrical current. Resonance amplifying effects. All documented phenomena, all technically feasible, all potentially applicable at architectural scale. The barrier is not physics but engineering, designing structures that resonate at precise frequencies, constructing them from materials with the right properties, calibrating them to local electromagnetic conditions, maintaining them to preserve their acoustic characteristics. These require sophisticated knowledge and careful execution. If such knowledge existed and was then lost, rediscovering it through modern experimental science would be a slow process, reinventing from first principles what might once have been refined through generations of practical application. The evidence suggests that this knowledge did exist, was applied in buildings across a vast region, and was then systematically erased through architectural destruction and archival suppression. Whether this was deliberate suppression of a threatening technology or merely the consequence of modernization and ideological purging is impossible to determine from the fragmentary record that remains. The result is the same: a technology forgotten, its principles lost, its existence denied by official history, leaving only scattered traces in archives and archaeology. If the buildings could speak, they might tell their purpose, but the buildings have been demolished. What remains are photographs, documents, and questions without answers. The mystery persists, built into the foundations of structures that no longer stand, written in reports that were classified and filed away, waiting in archives for someone to ask the right questions.